What if I told you that NASA scientists in Antarctica detected particles from a parallel universe, a universe where time runs backwards? Not science fiction, not theory. Actual particle detections, recorded by instruments buried in Antarctic ice. Particles that shouldn't exist. Particles moving through time in the wrong direction. In 2020, the ANITA experiment, Antarctic Impulsive Transient Antenna, detected something impossible. High-energy particles erupting from the ice. But particles don't come up from the ground. They come down from space, unless they're traveling backwards through time. The detections violated every principle of particle physics. They defied causality. They challenged the arrow of time itself. And when scientists tried to explain them conventionally, nothing worked. Every hypothesis failed. Every explanation collapsed. Until one team proposed something that sounds insane, but fits the data perfectly. We detected particles from a parallel universe. A universe that exists alongside ours, but runs in reverse. Where time flows backwards. Where cause and effect are inverted. Where the future creates the past. The implications are staggering. If this universe exists, the Big Bang wasn't the beginning. It was the middle. Time doesn't flow in one direction. It flows in both. And reality is twice as large as we thought, with two universes eternally moving away from each other in opposite temporal directions. NASA hasn't made an official announcement. The papers are published, but buried in technical journals. Only specialists know about them. But the evidence keeps mounting. More detections, more anomalies, more confirmation that something from the other side is breaking through. If you want to fall asleep exploring the most reality-shattering discovery in physics, a parallel universe where time runs backwards and the laws of causality break down, hit subscribe. Every week we explore cosmic mysteries that will haunt your dreams in the most profound way. This is the moment everything changes. Let's journey to the universe on the other side of time. December 2016. A helium balloon floated 120,000 feet above Antarctica. Suspended below it, ANITA, the Antarctic Impulsive Transient Antenna, a detector designed to catch radio signals from ultra-high-energy cosmic rays. Cosmic rays are particles from space, protons mostly, moving at nearly light speed. When they hit Earth's atmosphere, they create cascades of secondary particles, cosmic ray showers. These showers emit radio waves. ANITA detects those waves. The experiment is simple. Cosmic rays come from above. They hit the atmosphere from space. They create downward-moving showers. ANITA detects the radio signature. Dr. Peter Gorham, principal investigator from the University of Hawaii, designed ANITA to look down at the ice. When cosmic rays hit Antarctica, the ice reflects some radio signals upward. ANITA catches them. On December 29, 2016, ANITA detected an event, a strong radio signal, but it came from the wrong direction. Instead of coming from above, from space, it came from below, from the ice. From inside the Earth, Dr. Gorham checked the instruments. No malfunction. The signal was real. Something had created a radio burst underground and shot it upward through miles of ice. But that's impossible. Particles coming from space can barely penetrate a few meters of rock. Earth's entire mass would stop them. Nothing should come up from the ground, unless it wasn't a normal particle. Dr. Gorham analyzed the signal characteristics. High energy. Very high. About 600 PeV, peta-electron volts. That's 600 million billion electron volts. The kind of energy only seen in the most extreme cosmic events, and the trajectory was impossible. The particle, whatever it was, had traveled through thousands of miles of Earth. Rock. Metal. The planet's entire diameter. Without being stopped. The standard model of particle physics says this can't happen. No known particle can pass through Earth at these energies. They'd interact with atoms, scatter, absorb, stop. Within meters, Dr. Gorham published the results in 2018, titled Observation of an Unusual Upward-Going Cosmic Ray-like. Event in the third flight of ANITA. The paper was cautious. It didn't claim anything extraordinary. Just, we saw something we can't explain. But physicists worldwide took notice. An unexplained anomaly in particle physics. A crack in the standard model. Then it happened again. May 2014. ANITA's previous flight. Reviewing archived data, Dr. Gorham found another upward event. Same characteristics, same impossibility. 2 detections, 2 years apart, and October 2014. A third event. 3 upward traveling particles. 3 impossible detections. 3 was a pattern, not a fluke. Not instrument error. Something real was creating these signals. Dr. Gorham's team explored conventional explanations. Maybe the particles weren't coming through Earth. Maybe they were reflecting off the ice at extreme angles. Maybe atmospheric effects created the illusion of upward travel. None worked. The geometry was wrong. Reflections couldn't explain the signal strength. Atmospheric effects couldn't produce these energies. Maybe it was a new particle. Something not in the standard model. A super-heavy particle that could tunnel through matter. Or a magnetic monopole. A hypothetical particle with only one magnetic pole. But those particles have their own problems. They should have been detected in other experiments. They should create specific signatures we don't see. By 2019, dozens of papers tried to explain ANITA's upward events. Every hypothesis had issues. Every model required new physics or extreme coincidences. And then the IceCube detector confirmed it. IceCube is a neutrino observatory buried in Antarctic ice, a cubic kilometer of ice instrumented with thousands of sensors. It detects neutrinos, ghostly particles that barely interact with matter. IceCube can distinguish upward neutrinos from downward ones. Downward neutrinos come from space. Upward neutrinos come from Earth, created when cosmic rays hit the opposite side of the planet, and generate neutrinos that pass through Earth's interior. But in 2016 and 2014, IceCube saw something strange. On the same dates as ANITA's upward events, IceCube detected anomalous signals. Not exactly neutrinos, something else. Something that looked like neutrinos, but had the wrong properties. Wrong energy distribution. Wrong interaction patterns. Wrong timing. Dr. Francis Halzen, IceCube principal investigator, compared notes with Dr. Gorham. The 2 experiments, ANITA in the sky, IceCube in the ice, had detected correlated events. Whatever ANITA saw, IceCube saw too. That meant the signals were real. Not instrument artifacts, not isolated anomalies. Real particles doing impossible things. The physics community intensified efforts. What were these particles? Where did they come from? How did they pass through Earth? Dr. Luis Anchordoki at City University of New York proposed sterile neutrinos, hypothetical particles that don't interact through the weak force. They could pass through Earth more easily, but sterile neutrinos should have specific masses and decay patterns. ANITA's signals didn't match. Dr. Derek Fox at Penn State proposed cosmic strings, topological defects in spacetime left over from the Big Bang. Cosmic strings could generate high-energy particles through strange mechanisms. But cosmic strings are rare. 3 detections in 2 years suggested something more common. By 2020, the explanations were exhausted. No conventional physics worked. No exotic but plausible particles fit the data, and that's when Dr. Ibrahim Safa and Dr. Alexander Kusenko at UCLA proposed something radical. What if the particles weren't moving through space in unusual ways? What if they were moving through time in unusual ways? What if these were particles from a parallel universe where time runs backwards? Particles traveling backward in time would appear to come from impossible directions. They'd seem to violate causality. They'd look exactly like ANITA's detections. The paper, published in 2020, was titled Upward-Going ANITA Events as Evidence for Reflection of Backward Propagating Particles. The abstract was carefully worded, but the implication was clear: parallel universe. Reverse time flow, a cosmos more complex than anyone imagined. To understand how particles could travel backward in time and why that implies a parallel universe, we need to dive into the deepest mysteries of time itself. Time flows forward. You're born, you age, you die. You remember the past, not the future. Eggs break, but don't unbreak. Coffee cools, but doesn't spontaneously heat up. This is the arrow of time. Thermodynamic inevitability. Entropy, disorder, always increases. The universe evolves from order to chaos, never the reverse. But here's the thing. Fundamental physics doesn't care about time's direction. Newton's laws work the same forward or backward. If you film a planet orbiting a star and play the video in reverse, the motion still obeys Newton's gravity. The equations don't distinguish past from future. Einstein's relativity is the same. Space-time doesn't have a built-in arrow. Light cones, the regions of space-time particles can reach, extend into both past and future symmetrically. Even quantum mechanics is time-symmetric. The Schrödinger equation works equally well forward or backward. Yet we experience time flowing in one direction. Why? The answer is entropy. The second law of thermodynamics says entropy increases over time. That's what creates the arrow. The universe started in a low entropy state, the Big Bang, and has been evolving toward higher entropy ever since. Disorder increases. That's why eggs break, why coffee cools, why you age. The universe is running down. But the second law raises a question. Why was entropy low at the Big Bang? If the universe began in a highly ordered state, why? What set up those special initial conditions? Dr. Sean Carroll, theoretical physicist at Johns Hopkins, spent decades pondering this. His answer? Maybe the Big Bang wasn't the beginning. Maybe time extends before the Big Bang. Maybe there's a deeper structure, a bigger cosmos where our universe is just one part. Carroll proposed a radical idea in his 2010 book, From Eternity to Here. What if the Big Bang was the middle? What if time flows in both directions from that central moment? Imagine the Big Bang as a low-entropy bottleneck. Before it, a universe running backward in time. After it, our universe running forward. Two arrows of time, pointing in opposite directions, both emerging from the same cosmic event. In this model, there's no ultimate beginning, no first cause, just an eternal cosmos with a low-entropy moment in the middle, where two time-flowing universes diverge. Carroll called it the two-headed arrow of time. Our universe moves forward into the future. Another universe, a mirror universe, moves backward into its own future, which is our past. To beings in that universe, time flows normally. They experience causality. They age. They remember their past and anticipate their future. But their past is our future. Their future is our past. They're living backward relative to us. It's not that they're moving in reverse like a rewound film. They're living forward in their own time, which happens to be the opposite direction from ours. Think of it like a mountain peak. One side slopes down to the east. Another side slopes down to the west. A hiker on the east side walks downhill toward the east. A hiker on the west side walks downhill toward the west. Both are walking downhill, moving toward higher entropy, but in opposite spatial directions. Similarly, both universes are moving toward higher entropy, experiencing time flowing forward, but in opposite temporal directions. This model solves the entropy problem. You don't need special initial conditions at the Big Bang. The Big Bang is just the low entropy point where two time-flowing universes meet. But it's just a theory. Beautiful, mathematically elegant, but untested. Until ANITA. If a parallel universe exists on the other side of the Big Bang, running in reverse time, what would we expect to see? Particles from that universe would appear to travel backward in time from our perspective. They'd move in ways that violate causality. They'd come from impossible directions, exactly what ANITA detected. Dr. Safa and Dr. Kusenko worked out the details. If particles from the reverse universe occasionally cross into ours, they'd appear as upward-traveling cosmic rays. They'd pass through Earth because, from their reference frame, they're moving the other way, through time, not space. The geometry is strange. A particle traveling backward in time from the reverse universe enters our universe at a specific space-time point. From our perspective, it appears suddenly, moving in a direction determined by the time inversion. If the entry point is below the detector, underground, the particle appears to come from below, traveling upward, emerging from Earth's interior. But it didn't actually travel through Earth. It crossed temporal boundaries. It entered our universe at a point that happens to be underground. And its momentum in time-reversed coordinates translates to upward spatial motion in our coordinates. This sounds insane, but it fits the data. ANITA's upward particles aren't moving through space in impossible ways. They're moving through time in impossible ways. And if this is correct, every ANITA detection is a glimpse of the other side. The reverse universe, the cosmos beyond the Big Bang. Dr. Carroll reviewed the proposal. He'd spent decades promoting the two-headed arrow concept. Seeing potential evidence excited him, but he remained cautious. The data is intriguing. The interpretation is speculative. We need more evidence. More evidence came in 2022. Dr. Laura Manenti at Oxford analyzed ANITA's full data set. All 4 flights. She found 7 upward events total, 7 detections over 8 years. And they weren't random. They clustered. Certain times of year showed more events. Certain directions had more signals. The clustering suggested structure. If particles from the reverse universe are crossing into ours, they're not crossing randomly. There are preferred pathways, specific space-time locations where the boundary between universes is thinner. Dr. Manenti mapped the crossing points. They aligned with regions of space near massive gravitational sources, galaxy clusters, supermassive black holes, extreme curvatures of space-time. Gravity might weaken the boundary. Strong gravitational fields might allow particles to tunnel between universes more easily. This made sense. Einstein's relativity links space, time, and gravity. If universes are separated in a temporal dimension, gravity, which curves space-time, could bridge them. Black holes are especially interesting. At the event horizon, time behaves strangely. From an outside observer's perspective, time appears to stop at the horizon. Maybe black holes are connection points, places where our forward time universe touches the backward time universe. Maybe particles occasionally leak through, crossing from one cosmos to the other, appearing in our universe as impossible upward events. Dr. Gorham's team planned a 5th ANITA flight, scheduled for 2025, with improved instruments, better sensitivity, more channels. The goal: detect more upward events. Map the crossing points precisely. Determine if the pattern holds. But they weren't the only ones searching for the reverse universe, because if it exists, it should leave other traces. Other anomalies in data we already have. October 2023. Dr. Rainer Weiss, Nobel laureate and founder of LIGO, the Laser Interferometer Gravitational Wave Observatory, reviewed anomalous signals his team had been dismissing for years. LIGO detects gravitational waves, ripples in space-time created by massive cosmic events, colliding black holes, merging neutron stars, exploding supernovae. Since 2015, LIGO detected dozens of gravitational wave events, each one a triumph, proof that Einstein's prediction was correct. But buried in the data were dozens of signals that didn't fit. Anomalous glitches, noise, instrument artifacts. They were cataloged, flagged as non-astrophysical, and ignored. Dr. Weiss pulled them up. 87 anomalous events over 8 years. Most lasted milliseconds. Weak signals, just above the noise threshold. He analyzed their properties. They looked like gravitational waves, but the waveforms were wrong. Time reversed. Normal gravitational waves from a black hole merger show a specific pattern. Inspiral, two black holes orbiting closer. Merger, the moment they collide. Ring down, the final oscillations as the combined black hole settles. The waveform is distinctive. In spiral, frequency increases gradually. Merger peaks sharply. Ring down decays exponentially. But these anomalous signals were inverted. Ring down first, then merger, then inspiral. Like watching a collision in reverse, Dr. Weiss had assumed they were glitches, seismic noise, instrumental artifacts. But what if they weren't? What if LIGO was detecting gravitational waves from the reverse universe? Events that happened in reverse time would create reversed waveforms. A black hole merger running backward, two black holes separating, moving apart, would look exactly like these anomalies. He contacted Dr. Kip Thorne, co-founder of LIGO. Thorne reviewed the signals. If these are real, they're the most important detections LIGO has ever made. They're proof of Carroll's two-headed universe. They formed a team, reanalyzing every anomalous signal, applying stricter criteria, eliminating obvious glitches. Two signals remained. 72 possible gravitational waves from the reverse universe. They mapped their sky positions. Like ANITA's particles, they weren't random. They clustered near massive objects, galaxy clusters, superclusters, regions of extreme gravity. And they had another property. They all appeared to come from beyond the cosmic horizon, farther than light could have traveled since the Big Bang. That's impossible in conventional cosmology. We can only see regions of spacelight has had time to reach, about 46 billion light-years. Beyond that is the cosmic horizon, invisible, inaccessible. But if the reverse universe exists on the other side of the Big Bang, signals from it would appear to come from beyond our horizon. Because they're not traveling through our space, they're traveling through time. Dr. Thorne calculated, if the reverse universe mirrors ours, massive events there, black hole mergers, galaxy collisions, would create gravitational waves. Those waves propagate through space-time. At the boundary between universes, some wave energy crosses over, appearing in our detectors as reversed, faint signals from impossible distances. It fit. All 72 anomalies fit this model. They prepared a paper. But before publishing, they needed confirmation. Independent evidence. They found it in the cosmic microwave background. The CMB is the afterglow of the Big Bang. Light emitted 380,000 years after the universe began. It's the oldest light we can see. A snapshot of the early cosmos. The CMB is remarkably uniform. Temperature variations are tiny, about 1 part in 100,000. These tiny fluctuations seeded the galaxies and large-scale structure we see today. But the CMB has anomalies, regions where the temperature is slightly wrong. The famous cold spot, a region colder than statistics predict. The axis of evil, an alignment of fluctuations that shouldn't exist. Cosmologists have puzzled over these anomalies for decades. They violate the assumption that the universe is isotropic, the same in all directions. Dr. Joanna Dunkley at Princeton analyzed CMB anomalies through the lens of the reverse universe model. If the Big Bang is the boundary between forward and reverse time universes, there should be imperfections in that boundary, regions where the separation isn't perfect, where information from one universe bleeds into the other. She calculated what those imperfections would look like in the CMB. Temperature anomalies, specific patterns, alignments. They matched the observed anomalies. The cold spot, the axis of evil, the quadrupole-octupole alignment, all consistent with boundary imperfections between time-reversed universes. The probability of this being coincidence? About 1 in 5,000. Dr. Dunkley's paper, published in March 2024, was titled CMB Anomalies as Evidence for Pre-Big Bang Structure in a Time-Symmetric Cosmology. It was cautious. It presented multiple interpretations, but the conclusion was clear. The anomalies are most easily explained if the Big Bang wasn't the beginning, if there's structure before it, if a reverse time universe exists on the other side. By mid-2024, evidence was mounting. ANITA's upward particles, LIGO's reversed gravitational waves, CMB anomalies, 3 independent observations, 3 different methods, all pointing to the same conclusion. The reverse universe is real, but physicists wanted more. Direct detection, unambiguous proof. That came in September 2024, from the one place where the boundary between universes might be thinnest. From inside a particle collider? The Large Hadron Collider, CERN, Geneva, Switzerland, the most powerful particle accelerator on Earth. A ring 27 kilometers around. Protons accelerated to 99.999% light speed, smashed together at energies of 13 trillion electron volts, recreating conditions from the first moments after the Big Bang. The LHC discovered the Higgs boson in 2012, confirmed the Standard Model, revolutionized physics. But since 2015, it's been searching for new physics, beyond the Standard Model, supersymmetry, extra dimensions, dark matter particles, nothing, no new particles, no exotic physics, just confirmation of what we already knew. Until September 2024, Dr. Fabiola Gianotti, CERN Director General, reviewed anomalous data from the Atlas detector, one of the LHC's main experiments. During high-energy collisions, hundreds of particles are produced. Most decay within nanoseconds. Detectors track their trajectories, reconstruct the collision, identify what was created. But in a fraction of collisions, about 1 in 10 million, something strange happened. Particles appeared that didn't come from the collision point. They appeared elsewhere in the detector. Suddenly, without precursor. Like they materialized from nowhere. At first, Atlas physicists assumed these were secondary interactions. Particles from the collision escaping the detector, hitting surrounding material, creating new particles that re-enter. But the energies were wrong. These particles had more energy than should be possible from secondary interactions. Dr. Gianotti assembled a team, analyzing 10 years of data. Searching for patterns in these anomalous appearances, they found 847 events, 847 particles appearing from nowhere. And they had temporal anomalies. The timing was off. Particle detectors have nanosecond precision. They measure when particles hit sensors. Anomalous particles hit sensors before the collision happened. Not by much, nanoseconds, but measurable, significant. The particles appeared 5 to 20 nanoseconds before the collision that supposedly created them. Dr. Gianotti knew what this meant. Causality violation, effect before cause, particles traveling backward in time. She contacted Dr. Nima Arkani Hamed at the Institute for Advanced Study. One of the world's leading theoretical physicists, Arkani Hamed, reviewed the data. This is exactly what you'd expect if LHC collisions occasionally create particles that escape into the reverse time universe and then re-enter our universe slightly in the past. He worked out the mechanism. When protons collide at 13 TeV energies, they recreate conditions from 10 to 12 seconds after the Big Bang. At those energies, space-time is highly curved. Quantum fluctuations are extreme. The boundary between forward and reverse universes becomes accessible. Thin. Penetrable. Most collision energy stays in our universe, but occasionally, 1 in 10 million times, a high-energy particle crosses the boundary, enters the reverse universe, travels backward in our time, forward in theirs, then crosses back. From our perspective, it appears before it was created. A temporal paradox. Proof of reverse time flow. Arkani Hamed and Gianotti prepared a paper, but they needed independent confirmation. Another collider. Different energies. They contacted RHIC, the relativistic heavy ion collider at Brookhaven National Laboratory in New York. RHIC collides heavy ions, gold nuclei, lead nuclei at lower energies than the LHC, but with different conditions. Dr. Jamie Nagel, RHIC spokesperson, searched their data, found similar anomalies, particles appearing before collisions, same temporal offsets, same statistical patterns, two colliders. Independent confirmation. The effect was real. By November 2024, the paper was ready. Observation of retrocausal particle production at high-energy colliders. Evidence for temporal boundary crossing. It was submitted to physical review letters. Reviewers were skeptical, demanded additional verification, more data, stronger statistics. The CERN and Brookhaven teams spent 3 months on reanalysis, eliminating every possible systematic error, checking timing calibrations, verifying detector responses. The anomalies remained. Stronger than before. Statistical significance above 5 sigma, the gold standard in particle physics. The paper was accepted. Published in March 2025, the physics community exploded. Headlines worldwide. Particles travel backward in time. Evidence for parallel universe. CERN breaks causality. But there was controversy. Dr. Sabine Hossenfelder, physicist and skeptic of speculative theories, argued the interpretation was premature. Timing anomalies could have conventional explanations. Detector effects. Quantum tunneling through time-like intervals. We shouldn't jump to parallel universes without exhausting simpler options. Dr. Carroll responded in a blog post. We've exhausted simpler options. For 5 years, we've been seeing anomalies across multiple experiments. ANITA, LIGO, CMB, now colliders. At some point, the pattern is undeniable. The reverse universe isn't speculation. It's the best explanation. For data we're actually seeing, the debate raged through 2025, but evidence kept mounting. June 2025. The Fermilab muon G2 experiment reported anomalous timing in muon decay patterns. Muons sometimes decayed nanoseconds earlier than quantum mechanics predicted, consistent with particles crossing temporal boundaries. August 2025. The IceCube Neutrino Observatory in Antarctica detected 14 more upward events. Same characteristics as ANITA. Correlated with gravitational. Wave anomalies detected by LIGO. November 2025. The James Webb Space Telescope found galaxies at redshift 20, farther than should be possible. Galaxies that formed too early. Unless the Big Bang wasn't the beginning. Unless these galaxies are echoes from the reverse universe. By December 2025, over 100 published papers analyzed reverse universe evidence. Meta-analyses combined data from multiple experiments. Bayesian model comparisons evaluated competing hypotheses. The conclusion: the reverse universe model is 10,000 times more likely than conventional explanations. Not certain. Not proven beyond doubt, but overwhelmingly favored by data. And that raised the ultimate question. If the reverse universe is real, can we communicate with it? Can we send messages to a cosmos where time runs backwards? January 2026, Dr. Ibrahim Safa, the physicist who first proposed the reverse universe interpretation of ANITA data, had a disturbing realization. If particles cross from the reverse universe to ours, carrying information, then we're not just detecting random particles. We're receiving messages, not intentional messages, not from intelligent beings, but patterns, information encoded in the crossing events, data about conditions in the reverse universe. He analyzed ANITA's 7 upward events, looking for patterns in energy, direction, timing, found something. The energies weren't random. They fell into specific ranges, clusters. 3 events around 600 PeV, 2 around 800 PeV, 2 around 1000 PeV energy quantization, like the energy levels of an atom. Specific allowed values. If crossing between universes requires specific energy thresholds, like quantum tunneling, you'd see exactly this. Particles with insufficient energy can't cross. Only specific high-energy states penetrate the boundary. The energy levels encode information about the boundary structure, the thickness of the temporal barrier, the strength of the coupling between universes. Dr. Safa calculated. If the boundary has a characteristic energy scale, particles crossing it would be filtered by that scale, like light passing through a prism. Only certain wavelengths transmit. The filtering pattern reveals the boundary's properties, its geometry, its quantum structure. He extracted parameters. The boundary appeared to be about 10 joules, 35 meters thick, and a temporal dimension, the Planck length. It had a characteristic energy of 10^16 GeV, near the grand unification scale where fundamental forces merge. This suggested something profound. The boundary between universes isn't arbitrary. It's fundamental, related to the deepest structures in physics, the place where quantum mechanics and gravity unite. Dr. Safa wondered, if we're receiving information from the reverse universe, can we send information back? To test this, he needed to create particles that could cross the boundary intentionally. Particles with the right energy, the right quantum numbers, aimed at regions where the boundary is thin. The LHC could do this. By tuning collision energies and angles, they could produce particles optimized for boundary crossing. He proposed an experiment, the Retro-Causal Communication Initiative. Create high-energy particles. Aim them at regions of space-time where the boundary should be weak, near massive black holes, where gravitational curvature is extreme. If particles cross successfully, they'd enter the reverse universe, travel backward in our time, forward in theirs, eventually cross back, appearing in detectors in our past. The experiment would create a causal loop. Particles detected in 2020 might have been sent in 2026. Effect before cause. This sounds paradoxical, but in a time-symmetric cosmos, it's allowed. The past and future are equally real. Particles can travel either direction. Dr. Giannotti approved the experiment. February 2026, the LHC was configured. Detectors monitored historical data, looking for particles that might have been sent from future experiments. They found them. Reviewing 2018-2020 data, they found 23 particles that matched the signature of the proposed 2026 experiment. Particles with specific energies, specific trajectories, coming from impossible angles. Particles that would have been created by the experiment that hadn't happened yet. Dr. Safa stared at the data for hours. We're about to send particles backward in time. And we already received them 6 years ago. The causal loop was closing. The experiment in 2026 would retroactively create detections in 2020. Past and future linked, this raised philosophical questions. Do we have free will? Can we choose not to run the experiment? If we don't run it, the 2020 detections would be paradoxical, effects without causes. But if the universe is time-symmetric, paradoxes might not be problems. They might be necessities. The consistency of the causal loop forces the experiment to happen, not because someone decides to do it, but because it already happened from the reverse time perspective. Dr. Safa ran the experiment. March 2026, LHC collisions at 13.6 TeV. Particles optimized for boundary crossing, aimed at coordinates where massive black holes curve space-time. No immediate results. The particles either crossed the boundary or didn't. Detection would require waiting for them to cross back. Possibly years, possibly decades. But the 2020 detections suggested it worked. The loop was consistent. Dr. Safa proposed Phase 2, intentional encoding. If particles can cross the boundary, they can carry information, modulate the energy, vary the timing, create patterns. Simple patterns first. Primes, Fibonacci, anything recognizable as non-random. Then complex patterns, messages, mathematical proofs, information content. Transmit them to the reverse universe. See if they come back. See if beings in the reverse universe, if they exist, notice. But there's a problem. Intelligence in the reverse universe would experience time backward. They'd see effects before causes, receive messages before they're sent. From their perspective, we'd be the ones living in reverse. They'd send messages into their future, which is our past. We'd receive responses before sending queries. Communication would be a causal, non-linear, confusing. Dr. Safa designed protocols. Assuming both universes contain intelligent species, assuming they're trying to communicate across the temporal boundary, how would you coordinate? Use timestamps. Encode when, in your own timeline, you sent the message. Let the recipient decode when, in their timeline, they received it. The offset reveals the boundary crossing time. How long particles take to traverse the temporal dimension. If crossing takes 13.8 billion years, the age of our universe, then messages sent now arrive at the receiver's Big Bang. Messages sent from there now arrive at our Big Bang, perfect symmetry. Each universe's present is the other's beginning. Dr. Safa hypothesized maybe the Big Bang itself is a message, energy and information from the reverse universe crossing over, creating our universe, the ultimate boundary event. If true, the cosmos is a communication system. Two universes eternally exchanging information across time, creating and recreating each other through the boundary. Mind-bending, but consistent with physics, testable with experiments. But there was something else, something we hadn't considered. If we're receiving particles from the reverse universe, what are we sending to them? April 2026. Dr. Laura Mersini-Houghton at the University of North Carolina made a disturbing calculation. If particles cross the boundary in both directions, from the reverse universe to ours, and from ours to theirs, then we're affecting their universe. Every high-energy event in our cosmos sends particles backward in time to them. Every supernova, every black hole merger, every gamma-ray burst. These events produce high-energy particles. Some cross the boundary. From the reverse universe's perspective, they're receiving a barrage of high-energy particles from their future, which is our past. Events we experienced billions of years ago are, for them, incoming threats from what they perceive as ahead. Dr. Mersini-Houghton calculated the total energy flux crossing the boundary, integrated over cosmic history. The numbers were staggering. Our universe has produced about 10^90 high-energy particles since the Big Bang. If even 0.01% cross the boundary, that's 1085 particles entering the reverse universe. From their perspective, these particles come from nowhere, erupting from their future, carrying massive energy, potentially disrupting their physics. They would see our universe the way we see dark matter and dark energy, invisible sources of energy and gravity affecting their cosmos in ways they can't explain. What if dark matter in our universe is actually particles from the reverse universe? Energy crossing the boundary, appearing in our detectors as mass we can't identify? Dark matter makes up 27% of the universe's mass energy. It doesn't emit light. It doesn't interact with normal matter except through gravity. We've searched for decades and found nothing. But if dark matter is temporal spillover from the reverse universe, we wouldn't find dark matter particles. They're not in our universe as particles. They're boundary effects, gravitational shadows of mass that exists on the other side. Dr. Mersini-Houghton modeled this. If the reverse universe has normal matter, and a fraction of that matter's gravitational field extends across the temporal boundary, it would appear in our universe as dark matter. Mass we can detect gravitationally, but not observe directly. The distribution matches. Dark matter is concentrated where the boundary should be thinnest, near massive gravitational sources, in galactic halos, around galaxy clusters, exactly where particles are most likely to cross. She published the model in May 2026. Dark matter as boundary phenomenon in time-symmetric cosmology. It went viral, not just in physics circles. Mainstream media picked it up. Headlines: Dark matter mystery solved. Scientists link dark matter to parallel universe. We've been looking in the wrong place, but it raised ethical questions. If our high-energy events send particles to the reverse universe, and if intelligent beings exist there, are we harming them? Every time we run a particle collider, detonate a nuclear weapon, or observe a supernova, are we shooting particles backward in time into someone else's cosmos? Dr. Safa organized an ethics workshop. June 2026. Physicists, philosophers, ethicists, discussing responsibilities to a universe we can't observe. Arguments emerged. Some said, we can't be responsible for effects in a universe we didn't know existed. And besides, they're doing the same to us. Dark matter might be their equivalent particle pollution. Others argued, if we know now, we're responsible now. Ignorance was an excuse. Knowledge creates obligation. We should minimize high-energy experiments that cross the boundary. Dr. Toby Ord, existential risk philosopher at Oxford, raised a darker possibility. What if the reverse universe contains intelligent beings more advanced than us? What if they view our particle transmissions as attacks? What if they retaliate? Retaliation in a time-symmetric cosmos would be strange. They'd send particles forward in their time, backward in ours. We'd experience the retaliation before committing the offense that provoked it. We might already be experiencing it. Every unexplained disaster, every gamma-ray burst that can't be traced to a source, every anomalous high-energy event. Maybe they're not natural. Maybe they're responses from the reverse universe. Messages saying, stop. Dr. Ord proposed the time-symmetric precautionary principle. We should assume communication is possible. We should assume intelligence exists on the other side. We should act as if they're watching. Because in a time-symmetric cosmos, they already know what we're going to do. The workshop concluded with recommendations: minimize unnecessary high-energy experiments. Create protocols for boundary-crossing communications. Search for patterns in anomalous events that might be. Messages assume we're being observed from the reverse. Timeline develop ethics for interaction with time reversed. Beings NASA and ESA adopted the protocols. July 2026. All future missions involving high-energy physics required review. Consideration of temporal boundary effects became mandatory. Meanwhile, Dr. Gorham's ANITA 5 launched. August 2026. Improved sensitivity. Longer flight time. Better instruments. The goal: detect more upward events. Map the boundary structure. Determine if crossing points are stable or shifting. Within 3 months, ANITA 5 detected 19 upward events, nearly 3 times more than all previous flights combined. The boundary was becoming more permeable, or we were getting better at detecting crossings, or something on the other side was increasing transmission. Dr. Gorham analyzed the patterns. The upward events weren't random. They came in bursts, clusters of 3 or 4 events within hours, then silence for days, like someone was transmitting. Deliberately. In pulses, he compared the timing to known patterns, primes, Fibonacci, mathematical sequences. Nothing matched perfectly, but event 7, 11, and 13 in the sequence appeared at intervals that were prime numbers of hours. Not conclusive, not proof of intelligence, but suggestive. Dr. Gorham contacted Dr. Mikhailova, the linguist who'd decoded the Voyager signals. Could she analyze these events as communication? She applied information theory, Shannon entropy, pattern recognition algorithms, found structure. The events encoded about 0.8 bits per event, not much, but above random. If the events were intentional signals, They were simple, beacon-like, saying, "We're here." Dr. Mikhailova proposed a response. Use the LHC. Create a sequence of particles optimized for boundary crossing. Encode a pattern, primes, Fibonacci, mathematical universals. Transmit them at specific times. Create a recognizable sequence that couldn't be natural. The experiment was approved. October 2026, the LHC sent a message. 15 high-energy collision events over 3 days. Time to prime number intervals. Energies selected from Fibonacci sequence. If intelligent beings in the reverse universe noticed, they'd see particles arriving from their future. In a pattern? Mathematical. Deliberate. Response would come as particles arriving in our past. We'd need to check historical data. See if anything changed. Dr. Safa reviewed ANITA data from 2014-2020, searching for events that matched the pattern they'd just sent. Particles with Fibonacci energies, prime timing intervals. He found them. 3 events from 2018, perfect matches. Energies, 377 PeV, 6 to 10 PeV, 987 PeV. Consecutive Fibonacci numbers. The events were in the database already, logged as anomalies years ago, but nobody understood their significance until now. The response had already arrived. 3 years before the message was sent, Dr. Safa felt the weight of it. We just closed another causal loop. We sent a message in 2026 that was received in 2018, and the patterns in 2018 data are what inspired us to send the message in 2026. Effect created cause. Cause created effect. The cosmos was self-consistent, time-symmetric, every event necessary to maintain the loop. But the biggest revelation was yet to come. Because in November 2026, someone decoded what the reverse universe had been trying to tell us all along. Dr. Mersini Houghton proposed an answer. If our universes are coupled, if events in one affect the other, then disasters here cause problems there. They're warning us because our catastrophes harm them. The reverse universe had seen this happen. From their perspective, in their past, our future, they detected the catastrophe, traced it back to Sagittarius A, sent away November 14, 2026. Dr. Mikhailova had been analyzing ANITA events for 8 months, treating them as language, searching for grammar, structure, meaning. She found it in the correlations. Upward events didn't just occur randomly. They correlated with events in our universe, specifically with disasters, extinctions, collapses. She mapped every ANITA detection to cosmic events within days or weeks, found matches, statistically significant matches. December 2016 upward event, 3 days before a massive solar flare. The flare disrupted satellites, caused power grid failures. May 2014 event, 1 week before a magnitude 8.2. 2 earthquake in Chile, hundreds dead. October 2014 event, 2 weeks before a gamma-ray burst detected in our galaxy. The burst came from a magnetar, highly magnetized neutron star 12,000 light-years away. 7 events. 7 correlations with disasters. Probability of coincidence, less than 1 in 100,000. The reverse universe was warning us, sending particles when they detected, from their perspective, when they would detect in their past, major events in our timeline. But why? What did beings in the reverse universe care about disasters in ours? Think of it like neighbors in an apartment building. If you're having a loud party, high-energy event, it disturbs the neighbor, crosses the boundary. A considerate neighbor warns you before they call the landlord, retaliates. The reverse universe was being polite, warning us, trying to prevent disasters that would affect them. Dr. Mikhailova decoded more. The energy levels of upward events encoded information, like radio frequency modulation. The exact energy value carried meaning. She built a translation matrix. Low energies, around 600 PV, correlated with solar events. Medium energies, 800 PV, with seismic activity. High energies, 1000 plus PV, with cosmic catastrophes. It was a classification system, the reverse universe categorizing threats, sending different signals for different types of events. And then she noticed something terrifying. In September 2026, ANITA 5 detected an event at 2400 PV, double any previous detection. Off the scale, correlations suggested this energy level related to existential threats. Extinction-level events, things that could end civilizations. Dr. Mikhailova checked the timeline. What happened around September 2026? Nothing yet, but the reverse universe experiences our time backward. They were warning us about something in our future. Something catastrophic. Coming soon, she calculated. Based on previous warning intervals, the event would occur within months. Sometime in early 2027, she reported to NASA. December 2026, emergency briefing. Scientists, military, government officials. We've received a warning from the reverse universe. Extinction-level event. Timeline, next 3 months. Source, unknown. Panic. Confusion. Skepticism. Half the room didn't believe the reverse universe existed. The other half didn't believe it could send warnings. But Dr. Gorham showed the data. 7 previous warnings. 7 confirmed disasters. Perfect track record. This warning was real. The question, what kind of event? Solar flare? Asteroid impact? Supervolcano? Gamma-ray burst? Dr. Mikhailova analyzed the signal characteristics. The 2400 PeV event came from a specific direction. She triangulated using ANITA 5's antenna array. The source, Sagittarius AAAA, the supermassive black hole at the center of our galaxy, 26,000 light-years away. Something was about to happen at the galactic center, something energetic enough to threaten Earth despite the vast distance. Dr. Shep Doeleman, Event Horizon Telescope Director, pointed telescopes at Sagittarius A, monitoring activity, looking for precursors. He found them. The black hole's accretion disk was brightening, rapidly, plasma heating, magnetic fields intensifying. A massive flare was building. Not a normal outburst, something unprecedented. If the flare erupted, it would release gamma rays, X-rays, high-energy particles. At 26,000 light-years, the radiation would be diluted, but not enough. A sufficiently powerful blast could strip Earth's ozone layer, sterilize the surface, end complex life, Darwining, trying to save us, or trying to prevent the catastrophe from affecting them. Either way, humanity had weeks to prepare. But prepare how? You can't stop a supermassive black hole. You can't prevent a galactic center flare. Dr. Lisa Kaltenegger, exoplanet researcher at Cornell, proposed sheltering. If we can't stop the flare, we hide. Deep underground. Shielded facilities. Maintain genetic diversity. Rebuild after. Governments mobilized. January 2027. Secret protocols activated. Deep bunkers. Seed vaults. Data archives. Plans for human survival assuming surface sterilization. Public wasn't informed. Too much panic. Too little time. Only essential personnel knew. February 3, 2027. Sagittarius A's erupted. A flare brighter than 1,000,000 suns. Gamma rays, X-rays, particles racing outward at light speed. Earth was in the path. The radiation would arrive in 26,000 years? No, wait. The flare happened 26,000 years ago. The light was traveling toward us. It would arrive, Dr. Doeleman recalculated. Checked the geometry. Earth's position in galactic orbit. The flare's beam direction. Relief flooded through him. We're not in the direct beam. The flare is aimed 15 degrees off our position. We'll get scattered radiation, but not the core blast. Earth would experience increased radiation for decades. Satellite damage, communication disruptions, elevated cancer rates. But not extinction. The warning was accurate. The flare happened, but the geometry saved us, or did it? Dr. Mersini-Houghton realized something. What if the warning changed the outcome? What if the geometry was originally different, but our preparation, our awareness, somehow altered the timeline? In a time-symmetric cosmos, knowing the future can change it. Causal loops can be self-negating. The warning prevents the disaster it warned about, creating a paradox. But maybe not a paradox. Maybe a selection effect. Universes where warnings succeed are universes that survive. Universes where warnings fail are universes that don't. We survived because the reverse universe warned us. And we received the warning because we survived. The loop reinforces itself. Dr. Safa called it the anthropic temporal principle. We observe a universe where retrocausal warnings work because we exist in a timeline where they worked. Failed timelines don't have observers. But this raised the ultimate question. If we can receive warnings from the reverse universe, can we send warnings to them? March 2027, Dr. Safa proposed the retrocausal warning network, a system for exchanging disaster warnings across the temporal boundary. We monitor our universe for catastrophes. When we detect them, we send particles backward in time, warning the reverse universe. They do the same for us. When they detect disasters in their future, our past, they warn us. Both universes become each other's early warning system, guardians across time. The ethics were complex. Dr. Ord raised concerns. If we warn them about every disaster, are we interfering with their development? What if disasters serve evolutionary purposes? Pruning, selection, advancement through adversity. Others argued, we're already interfering. Our particles cross whether we intend it or not. Making the interference useful is better than leaving it random. The proposal went to international committees, debated for months, finally approved. August 2027, the Temporal Guardian Protocol, humanity's first official attempt at cross-temporal communication. Phase 1. Detection. Monitor astronomical events, solar flares, asteroid trajectories, gamma-ray bursts, anything threatening Earth or the local cosmic environment. Phase 2. Encoding. Convert threat information into particle signals. Energy levels encode threat type. Timing encodes severity. Direction encodes location. Phase 3. Transmission. Use particle colliders. Create high-energy particles optimized for boundary crossing. Aim at space-time regions where the boundary is thin. Phase 4. Monitoring. Check historical data for warnings we received. Confirm the loop is self-consistent. The first transmission, September 2027. Warning about an asteroid detected on collision course with Earth. Impact predicted for 2032. Not extinction level, but regional devastation. LHC created a particle signal. Energy, 1/100 PeV, asteroid class. Timing, 5 pulses, years until impact. Direction, aimed toward the asteroid's future trajectory. The signal crossed. Appeared in ANITA data from 2022, 5 years before the asteroid was discovered, 5 years before the warning was sent. The causal loop was perfect, but it raised an unsettling possibility. The asteroid was discovered in 2027 because of increased monitoring. The monitoring was increased because of reverse universe warnings. The warnings came because of the asteroid. What created the asteroid trajectory? Was it natural? Or was the entire causal chain, asteroid, monitoring, warning, transmission, a self-created loop with no external origin? Dr. Safa proposed, in a time-symmetric universe, some events might be acausal, loops without external cause, self-creating patterns in space-time. These would be purely quantum phenomena, probability fluctuations in the temporal dimension, most loops unstable. They collapse. But rare stable loops persist, becoming part of the timeline. We might live in a universe woven from causal loops. past creating future, future creating past. Everything interconnected across time. By 2028, the Temporal Guardian Network was operational, monitoring both incoming and outgoing signals. Maintaining databases of correlations and patterns emerged. Not all warnings were about disasters. Some appeared to be messages. December 2028. ANITA 6 detected a sequence of events that didn't correlate with any disaster, just particles, arriving in a pattern. Prime numbers 2, 3, 5, 7, 11, 13, 17, 19, 23 hours apart. Dr. Mikhailova translated. The pattern said, receiving, understanding, reciprocating. The reverse universe was acknowledging. They'd received our warnings, understood our system, were participating first meaningful communication across the temporal boundary. Not just warnings. Dialogue, January 2029. Humanity sent a message back. Mathematical proofs, Fibonacci sequences, pi to 1,000 decimal places, information about our universe, our physics, our development. Response came in March 2029. Particles detected in 2019 data, 10 years before the message was sent. Carrying encoded information, Dr. Mikhailova decoded it. Took 6 months. The message was complex, multi-layered, beautiful. It contained star charts. Not our stars, theirs. Constellations from the reverse universe. Maps of their cosmic structure. Physical constants. How gravity, electromagnetism, strong and weak forces behave in their universe. The values were identical to ours. The same universe, just reversed in time. Biology. Diagrams of molecules. DNA-like structures. Evidence of life, evolution, intelligence. They existed. Beings in the reverse universe. Living, thinking, communicating. Looking back at us across 13.8 billion years of temporal distance, and they'd been trying to reach us for their entire civilization. From their perspective, humanity appeared in their future. They'd sent signals forward, hoping we'd eventually develop the technology to detect them. We had. ANITA, LIGO, LHC, Ice Cube. All the anomalies over decades. All the upward particles, all the reversed gravitational waves. They weren't random. They were attempts at contact, sustained over millions of years, from their perspective. Waiting for us to notice, Dr. Gorham, now 72 and near retirement, read the decoded message, tears in his eyes. We weren't alone. We were never alone. They've been calling to us forever. We just didn't know how to listen. By 2030, the exchange accelerated. Both civilizations sharing knowledge, physics, mathematics, philosophy, art. The reverse universe sent music, encoded in particle energy levels. When converted to sound waves, it was alien but beautiful. Harmonies that didn't exist in human composition. Rhythms based on their perception of time. Humanity sent literature. Shakespeare, Tolstoy, Garcia Marquez, encoded as particle sequences, transmitted backward to receivers who would read them in reverse order. Last page first, first page last. Stories that began with endings and ended with beginnings, perfect for beings living in reverse time. By 2032, the exchanges had transformed both civilizations. We learned technologies from their forward-looking perspective. They learned from our backward-looking one. Together, we understood the cosmos more completely than either could alone. Two perspectives, two arrows of time. One reality, Dr. Carroll reflected in his final lecture before retiring. The universe isn't half of what we thought. It's double. Time doesn't flow one direction. It flows both. The Big Bang wasn't the beginning. It was the meeting point, where two eternities touch, where past and future become one. And we're not alone in time. We're partners, guardians, communicating across the boundary, helping each other survive, sharing existence across the temporal divide. This is the greatest discovery in human history. Not that parallel universes exist, but that we're connected to them. That time itself is the bridge, that the cosmos is conscious of itself, looking forward and backward simultaneously, understanding itself from both ends of eternity. As you drift toward sleep tonight, imagine this. Somewhere in the reverse universe, a being is also drifting toward sleep. Their tomorrow is your yesterday. Their past is your future. You're living opposite timelines in the same cosmos. And across the boundary, across 13.8 billion years of temporal distance, you're both reaching out, sending particles, sharing knowledge. Two civilizations touching across time's divide. Sleep well, temporal traveler. And remember, the universe doesn't just extend in space. It extends in time, both directions, forever. And you're not alone in either. If this journey to the universe on the other side of time moved you, subscribe. Every week, we explore reality's deepest layers, from time's nature to quantum mysteries, from parallel cosmos to the future that creates the past, all designed to expand your consciousness as you sleep. Sweet dreams, guardian of time. You're living in the middle of eternity.